Hello, this is checkpoint 2.40. They want us to find the volume of the parallelepiped formed by the vectors. So let's just generically set up three vectors, A, B, C, and provided that they are not all collinear or coplanar, which means they all lie on the same plane or lie on the same line, they're not all the same. They're going to span three-dimensional parallelepiped. So if two of them span a parallelogram, a two-dimensional parallelogram, the third one would actually span something similar. And we get like a skewed box that represents the parallelepiped. Now it turns out the volume of this is equal to the scalar triple product or triple scalar product, but you can take a look at the textbook for the proof of that. Here, let's just say that the volume is equal to there's also a possibility that the triple scalar product might be a negative number, so we usually take the absolute value of our triple scalar product. Okay, so let's find it. And remember that for the triple scalar product, we simply line up all the vectors in the matrix form and just find the determinant of the matrix. Instead of doing the cross product first and then the dot product, we can do it all together. Okay, A vector is 3, 4, negative 1. Our B vector is 2, minus 1, minus 1. And our C vector is 0, 3, 1. And our usual triple product is to expand on the top row, or usual cross product is to expand on the top row. But since we're looking at this as a determinant of a matrix, we can expand on any row or column that we want. And I'm going to choose to expand on the bottom row because there's a 0 here and then there's a 1. So that looks like it's a good combination. Again, each number in the matrix has an associated sign with it. So it alternates plus, minus, plus, minus, plus. And so expanding on the bottom row means that we're going to focus on this. All right, our first value is 0, and because it's 0, and the whole point why we chose that means we're not going to care about what the resulting submatrix is. It's just going to be multiplied by 0 anyways. The next is a negative 3, and the matrix associated with that, if we cross out the bottom row and the middle column, would give us a 3, negative 1, 2, negative 1. And then our last element is going to be 1, and then we cross out the bottom row and the last column, we're going to get a 3, 4, 2, minus 1. Okay. And remember, there's a negative sign in front of negative 2, but these are not the signs associated with the actual number. There are signs associated with the place that they sit in the matrix. Okay, back to this calculation. We have a negative 3, and then we have a negative 3 minus negative 2, and we have a 1 times negative 3 minus 8. Okay, negative 3, and this is going to be a negative 1 plus negative 11. This is positive 3 minus 11 is going to give us negative 8. but we want the absolute value of that. So let's take the absolute value of that. Volume is equal to absolute value of -8, which gives us 8. Okay, I hope that helps.